Let's look at orthogonal spheres. What are they? So let's see. Again, because we are talking in plurals, that means there has to be two spheres minimum. So let's create those U1, V1, W1 and D1, right? Similarly, U2, V2, W2 and D2. Okay. Now let's define the circles. Now because they are all same, uh, it will not form a sphere. Let's just move it a little bit here there. Okay, now equation of the sphere is x square plus y square plus z square plus 2u1 times x plus 2v1 times y plus uh, here u1 is 0.7, v1 is 2.6. Okay, plus 2w1 times z plus d1 is equal to 0. So we got the first sphere, right? Later on we will increase the graph space. Okay, now the second circle is x square plus y square plus z square plus 2u2 times x plus 2v2 times y plus 2w2 times z plus d2 is equal to 0. Yes, so we have got two spheres, not circles, spheres, and they are actually intersecting each other, right? Okay, it might happen that they are totally separate, they are not touching at all. So there are basically three scenarios. One is when they are not at all touching each other, one where they are just touching in such a way that they form a common tangent plane, and another option is what you see here, that is they are intersecting each other. Okay, now oh, you know, orthogonal spheres basically means that you have an intersection between these two spheres. So let's plot that intersect eq1 comma eq2. See here, this is the intersection. Okay, and now let's identify the centers, right? So c1 is equal to center of eq1. See here, c1, can you say it? So we have, this is the center of this sphere. Now similarly c2 is equal to center of eq2. This is the center of the other sphere. So if we rotate it, it will be clearer. Now let's connect this intersection with the centers. So what do we get? First of all, we have to identify a particular point on the intersection. So let's identify that point in what? In the intersection, that is C. So you see here, it has identified one point on the circle of intersection. Okay, now let's connect. So segment A, or let's say C1 comma A, and segment C2 comma A. So if I rotate it, it will be clearer what we are trying to do. Can you see that now? We are connecting the center of the spheres with the with a point on the circle of intersection. And this angle, if it is 90 degree, then it is a orthogonal spheres. Okay, so let's see what the angle between these two are. Angle G comma F, 89.39, very close. That is why it looks like 90 degree, right? So if we move it a little bit, take hold of any one of these variables and move it and see what happens to that angle. 89.39, 90.18. So which basically means that there is a certain combination of these which will make it exactly 90. The moment it is 90 degree, then we can say that these two spheres are orthogonal spheres. That means they cut each other at an angle of 90 degree with respect to their centers. So that is orthogonal spheres. Bye for now.